Okay, I want to do one more example of using L'Hopital's rule when you've got a limit, you're taking the limit of a rational function. And what I've done is I've chosen number 29 from the text. I'm going to go ahead and swing over to my iPad on this. And remember the situation that when you first come to a problem, this is number 29 there on the iPad, it's a matter of verifying first. If you take the limit of this rational function, if you plug in 1 to the numerator and plug in 1 to the denominator, if you get an indeterminate form of 0 over 0 or infinity over infinity, then it qualifies to use L'Hopital's rule. And what I want to say here is, let's just do that. You've got to do that in order to solve the problem, too. If you don't include that when you solve the problem, it will not be a correct use of L'Hopital's rule. Okay, you've got to check first to verify that it qualifies. And sometimes it will give you the wrong answer. Okay, if you take the derivatives before checking it. All right. So let's just go into this now. So what we're going to do is plug in the limit as x goes to 1 of the natural log of x. I'll do that right here on the bottom. And what we end up with is what? So that's the natural log of 1. And if you don't have that quite in your head yet, remember what that is, if you can plug it into your calculator to get it. But the question is, that's base e. E to what power equals 1? That is equal to 0. So you do get 0 on top. And if you plug in 1 to the denominator, you get 1 squared minus 1, which is 0 on the bottom. So you do get 0 over 0. And it qualifies. You can use L'Hopital's rule. And L'Hopital's rule says, now, if I take the derivative of the top of that, the numerator of that limit, and take the derivative of the bottom of that limit, the limit of that rational function will be equal to this original one. So what I'm going to do is I'm still taking the limit as x goes to 1, but I'm going to take the derivative of the top. The derivative of natural log of x is 1 over x. We'll get familiar with that soon. And the derivative of derivative of x squared minus 1 is 2x. So now, you plug in 1 to both of those. And that does give you 1 over 1 on top and 2 times 1 on the bottom, which is 1 over 2. So the end result is the limit as x goes to 1 of that function is equal to 1/2. Therefore, the limit of the original function, the limit of original rational function, limit as x goes to 1, is 1/2. Okay? That's another example. If you've got questions on that, let me know.